Hello everyone, and welcome back to the workshop. Right, today it's Sunday. I'm having a bit of a lazy time. I thought I'll do some board repairs that have come in. I don't know what we're going to find. Let's just get a rag to clean my glasses. So I've got, as you see on the table here, I've got 4 boards. And there's basically 3 different types. Right, glass is clean. I can actually see now. Makes a change. We've got a Mark IV square buzzer type, which is in the newer models of GHDs. I've got a Mark IV old style. So I've got all its auxiliary stuff connected, and I've got 2, looks like probably Mark V's, again with all the auxiliary stuff connected. Right, first thing I'm going to do is I want to reach up. I'm going to do an ESR check, normally on the capacitor at the back. Hopefully you can see this. It's been a little while since I've done a video. Had other things on my mind, like 2 car MOTs. Is that coming on? Yes. I don't know if the screen is coming up for you. Hopefully it will. Right, let's have a look. Let's just sort these connections out. Okay, let's just zero it. Did I zero it? There it is. I push and hold. Right, that's our probes zeroed. Quite often, let's get in frame probably. This capacitor on the back likes to go a bit loopy. This one's alright. It's reading 7.2 or 4 ohms. Anything over 10 is pretty on its way out. I've got one over here which has been removed. I don't know if it's duff or not. Let's have a look. Yeah, see, this one reads 47, so that's actually a duff one. I don't know why it's on my desk. Right, so that board's okay. Excuse me. We'll just quickly fire through these just to check. Right, 6.8 is definitely a goodie. What's this one? 7-ish, he's good. And 7, okay, that capacitor's good. I mean, that can throw, it's thrown me many a times to a point that I always check it first, because you can get some very strange behaviour where the processor boots, doesn't boot, intermittently resets. You can get some real strange behaviour. Right. Next thing I'm going to do is drag over me old faithful tester. Right, where's my power bank? Where are you? Oh, here you are. Right, let's plug you in. Okay, we've still got juice. Let's just power it up. Let's see what we get. Just clipping onto the PIC chip. Okay, that fired. Fired, and that said sensor error. Let me find myself a nice bit of metal. Right, if I just now short the sensor inputs and fire that chip, it shouldn't show sensor error. Okay, that's definitely shorted. Okay, the analog to digital converter is definitely shot on that chip, so that's a PIC chip. So there's a simple one. Right, let's try this one. Okay, that's 3 attempts, no life at all, so we'll try a PIC chip in that one. Okay, no life again in that one, so that's a PIC chip. The reason why I say it's a PIC chip, because I mean clipping straight onto it actually eliminates all the other components, apart from if you've got a shorted component which is stopping your power in the PIC. Okay, I must admit this video is going to be a bit more boring than normal. Sorry about that. Can't be helped, it's the way cookie crumbles. But basically what we're going to do, let's switch my soldering iron on. We'll have all these PIC chips out and replace them, and then we'll retest and see what we get. Right, let's get myself some solder. If nothing else, you can see how just removing and replacing the microprocessor. We've got the microscope on, so you can see in full glorious detail. Hopefully it's in colour. Let's have a look. I cannot see. Let me just check, make sure I've got the right. Actually, it looks in black and white. Let me tweak that. Configure video. Yeah, I'm not NTSC. Let's try the power there. Okay, we're in glorious Technicolor now. Or colour. I wouldn't call it Techni. Right. This board here is just because my screwy things on here are threaded. These are cheap boards, you buy them off of eBay for about £2 or £3. They're really good, apart from the threads in these are really crap. But if you have a suitable size, then that's fine. This one's actually a modified one. You buy them off eBay, they actually look like this. Not on screen yet. But I wanted 2 arms, so I actually broke up 2 to make 1. You can still see the original screw holes here and here. I just think it holds the board a lot nicer. If I had my brain in gear, what I would have done is used the actually I couldn't, because I've used this. I would actually put some springs in here as well, would make life a bit easier, but it doesn't really matter. But these are good for all types of board. You know, mobile phones, things like that. And I'll just use that. I use this old board just to tension the springs and keeps me board as solid. Right, first thing I'm going to do is I remove all the PIC chips. You've probably seen me do this before. And this is a case of add solder. You add solder to all the pins. You've just turned an 8-pin device into a 2-pin device, and now, just the same as you would change the R8s or R11s, we can whip that chip off. Follow up closely. A bit of soldery wick to clean the excess solder, and isopropyl alcohol, cotton bud, and we clean the board. That's ready. Right, let's just rip out these 4, do them all the same. This one's being obviously a bit more of a you know what, because it's still got its auxiliary hardware connected. Come on, have patience. It's starting to wobble, but we're not quite there yet. We don't want to force it because we'll take the tracks off and then we'll be in a load of doo-doo. Right, come on. Bit more. I'll actually utilise the microscope in a minute when we replace it, but at the moment I'm just box standard. Removing picks so we can put some new in. Third one. If you had a heat gun, you could probably use that. I actually think it's just as fast to do it this method. And I'm also not affecting anything in the vicinity. But whatever floats your boat on this, I'm afraid. Obviously this method just uses a soldering iron, so this is more accessible to the home gamer or whatever you want to call him or her. Because this definitely becomes a home repair, you don't need a hot air rework station or anything like that. Okay, last one. Chip removal. Come on, come on. Clean the iron. And clean the board. Drop the bottom, but I ain't gonna bother that. And clean the flux off. There we go. Right, let's get rid of these old chips. Now it's under the microscope time. Where are we looking at? It's not brilliant in there, but it will do. Okay. Tweeders. There they are. Right. Now I'm just going to do one pin. Oh, come here. Here's our PIC microprocessor. Are we in focus? That's better. Right. Okay, that's not too bad. Right. Get myself some thinner solder now. And let's stick it to the board. Stuck, that one's stuck, that one's stuck, that one's stuck, that one's stuck, that one, and we already did that one. Okay, that's one down. Next one. This is very much going to be a ×3, ×4 actually. It's 4 boards, can't count. Can't pick up microprocessors either. Is that the right way? Yeah, that's the right way. So there's a dot here, dot to dot. Sometimes there's an in cut here, depending on the silk screen. Come on. Did move last minute, but I think he's good. Right. Let's stick him down. 1, 2, 3, 4. 1, 2, 3. Okay. What I should do as well, which I didn't do with the other one, which I would do now. I'm just gonna clean any residue there. Okay, that's 2. These are different boards and they do use a different code in the microprocessor. I did actually have them ready because I did preempt that. These are going to be microprocessors. If it's not the R8 and R11, the microprocessor is generally at fault with these boards. I will get my fluke and check everything else. Actually, no, I won't. Yeah, well, I was going to say I'm going to run them up on my test board in a bit, and that will tell us if they're good or not, but I will check them. We're almost there. Get in. Right. Last but not least, this one. That's the wrong way around. Come on. Yep, that'll do. Alright, solder. Okay, that's looking good. And that one. Did I clean this one? Let's do it again. The whole board on that looks horrible, doesn't it? Yeah. Right. Let me just get my flute. Where are you? There you are. La 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 la. Right. Should be a measure. There should be about 100 ohms there. 102. Yeah. I actually measured R8 and R11 in one go. I've been a bit lazy. Let's move that out of the way. So you've got R8, R11. Is it there? Come on. Yep, he's good. Struggle a bit getting a connection. Yeah, it's good. If you can see, I've got one there, it's about 50 ohms, and I've got one resistor there, which is about 50 ohms. So we're all looking good at the moment. Just quick test. 101 ohms. Okay. R8, R11s are all good. Bring in the tester. Already gone. There it is. Bring in the tester again. Plug it in. See what we get now. Let's switch it on. Okay, again this one's showing sensor error, but then there's no sensor on it, so we expect that. Let's see if we can get that. try and get on the bottom. Still showing sensor error. Okay, this could be interesting because this is still showing the same fault. So maybe we haven't fixed this one at all. Let's go on, bridge. Okay, yeah, there's definitely something amiss with this one. Right, need to look into that one. What about these? These were dead. Let's have a look, see what we got. Okay, that's alive. Stay on. It's the only problem. See if I can clip on. It is bleeping. Hopefully you can hear it. Can't get on there. Okay. Heck of a state then. Come on. This is awkward. So I get purple eyes, I think. Okay, you had the note change. That's working. I need the board needs a good clean up. Do the same to this. Short it. Get blooming on. I think the only way is to try them all on my test bench, see what we get. I'm going to try one on my test bench. That's not conclusive. Let's just have excuse me. Let's just have a look at this. Focus. Give him a meter. Right. Okay, that one's working alright. And that one should come to about there. It should work. Definitely should work, so maybe let's do a bit of a clean on that. Probably need to clean a lot of these. Desoldering wick, let's just getting hot. Okay. I'm going to run that up on test bench. What's this one like? Oh, it looks awful. It does look awful. Where's my scrapper board? Let's try and clean that up a bit. Let's add a bit of solder. And then take away a bit. Oh my God, there's tons there. Okay, that's better. Clean. Another one cleaned. Alright. This one's actually not too bad. So we will clean it. Got a bit of braid there. I didn't clean the way through. Bugger. Let's move the microscope there. What's that? Oh, that's a bugger. I thought I'd done all the way through. Right. Bit of fresh solder. Okay, under the microscope, it's not too bad. There is a bit of solder resin there. Apart from that, it's very good. And the other side, last one. Let's see if we can do this one right. Under the microscope, please. Come on. Might have to do it from the other side. You see, it hasn't cleaned that left hand hole. Bit of a helping hand. And extract, oops, losing it. Come on. There we go, we're clear. Board clean. Nice and proper. Okay, right, that's 3 boards. I'm just going to go straight to the heavy testing. So I'm going to pause while I get the gear out. Okay, welcome back. Right, I've got my board out. What I've got here, this is just a case. It's actually empty here. As you can see, I haven't put, it's, yeah, you could say it's a real bodge. I've got a light bulb. This is going to be our load. I think it is a 60 watt light bulb. It is in picture, is it? Yes. Let me just turn off the microscope, because that'll give you a bit more bit more room on the screen. Right, where was I? Yeah, light bulb, that's the load. That's basically connected across the heaters. We have this to simulate the thermistor. It's marked at 100k, which is ambient temperature, 25 degrees. This markup here is the basically the set point. So we can now fully test this. This is a full live test. I'll actually take this off, make sure. As you see, I have an arrangement of pogo pins. So yeah, we just make sure it's sat in there, and then we actually test at full mains voltage. So it can go drastically wrong, and has done in the past. Right, let's see if this board's okay. Okay, nothing firing there, but then sometimes you don't get a good connection. There, I think that's alright. Switch on, go. Okay, we're firing. It's just telling me it didn't respond to heat. Okay, here's your LED on a dual colour. Let me just restart this. If I actually increase a bit of power, it will then think it's heating up. Alright, we've already seen the LED. Come on. It's not happy though. Okay, it's not happy. I'm not happy with that. It's not playing as it should. Just make sure it is seated. Which we may need to. Still not getting connection on these things. Okay, there is something amiss with this board, so we need to investigate a bit further. Right, let's try another board. This could be fun. I've never really tried it with the wires on. It actually should be alright, bar that red one. I think the red one's in the way. I'll just take off that red one. Sure this is not touching anything metallic, because obviously this is going to be pretty much live with it. Right, so 100 ohms, let's fire. That didn't fire at all. I am off, yeah. Again, it could be because it's a because I've got the other leads on. It's just a check. No, it should have fired. So he didn't fire at all. So he has more issues. Right. Not being very successful today, are we, chaps and chapettes? But then again, maybe I shouldn't have said, oh, it's not going to be all that exciting, but maybe it will be. And maybe I just got to take all these connections off. I'll find out on this one. If this arm don't want to tube, then I will. Nothing shorted. Nope, let's try. Okay, that's better. Increased, right. The LED's working. Let's fire up. Add temperature. Okay, that's a good board. That's a pass. Right. That's one good. Let's try this one. Hope I have 2 passes. Success rate's not very good today. Right. Oops, that slips. That's in its groove. Back to 100. That's not touching anything. It's all good, isn't it? Yeah. Try this one. LED, yeah. That's good. Area coming up. Absolutely superb. 2 passes. Right, that's 50% of them done. Let's have a look at this one. Why didn't you go? Let's have a. Let's just move that out of the way a minute. Right, okay, let's I will give it another go. Right, okay. Very good. No, he's definitely dead. Right, okay. Let's see if I can just move this out of the way. Come in. Let's have a look. Why would you be dead? Okay, supply to the PIC's not shorted. Let's go into our diode test mode. Right, okay, she's working. Get out of it. Okay, I'm not getting anything on this one. Right. Just have a look, see which. Which way we're supposed to get readings. Okay, red top. Okay, diode 2 is definitely gone. We've got something on the Zenith diode. Right. Find a scrappy board. Right. Okay, right. Here we go again. Let's fire up the microscope because this is definitely a microscopy jobby. Board holder. Right. I now have too many bits on here to work. Right, can I get there? Right, I'm after this diode here, D2, that seems to be dead. Soldering iron's still on, good. It's heavy off, he'll fly off in seconds. Because he's a super miniature thing. Right, he's off. Get away. Don't want you. It's clean enough for me. Okay, I'm just gonna rub one from here. Sorry it's out of focus, I'm just gonna take it off and drag it on. It's out of focus for me, but for what I'm doing. Yeah. Ouch, it's my finger. Tweeders! See if I can just, you can actually see how small this component is. It's absolutely minute. Okay, I think we've got it tacked. That's my solder. Let's take out the upper end. He good. Just check here and here. Okay, we have some juicy there. I'm worried about that. Was that just a mark or is that a... I measured that, that was 100 ohms, yes. And it's getting shorted through the board. Now I've never known these to go. And they are very high. So. It's got a reading there. Where is it? It's just a bit of flux, I think. Yeah, it's just a bit of flux. It just looked like it might have a bit of flux as well. Yeah. Oh, what's that? There's a bit of something. Okay, let's try it. So yeah, this is still in the picture. Let's just try it. Let's just see if we get any more luck. I'm actually doubting it's going to do anything, but I can be wrong. Okay, it's not shorted. Let's give it some juice. Oh, we're alive. Coming up with set point. power, less power, more power, less power. You can't see the light bulb, sorry about that, ladies and gentlemen. More power, less power, more power, less power. That's a working board. Now we're getting more successful, aren't we? Right, that's 3. 3 out of 4, good. And where was that funky little screw that I took out of here? Come on, where are you? There he is. Right, that's 3 done, and just this oddball left, which was very temperamental, wasn't it? So let's have a little pokey around. Okay, that seems to be okay. That seems to be okay. See if I'm just... Yeah, that's okay. That's just a quick capacity test. Right. Well, let's just try this one out again. Give a bit of a clean on the board. Because sometimes it did work, sometimes it didn't. Maybe it's just a case of a real stubborn, dirty connection. Alright, let's get that clamped in. Give that good. Hopefully get them to bite in a bit. Right, got me lights. Let's do there. See what we get or don't get. There's definitely a bad connection. So I heard it. Come on, you bugger. Just trying. Okay. Trying and it does. What can you be? Tested that capacitor. Could be. It's just could be this one. Maybe I need to test the ESR on this. Let's have a look. She's off. ESR meter. Again, we're looking for a nice low value. Got a table here which tells me how bad it should be. See if we can clip onto it. Actually, this is actually saying it's a dead short. Okay, that's actually showing it is a dead short. Or nigh on, so that's not very good. Let me just get my spares a minute. See what we would expect out of a new one. Just seemed really low. Actually 0.1 of an ohm, which is damn sight better than a dead short, which was 0.00 or whatever it was, 3 something. So I'm going to re-establish that with a new one, I think. Right. See if I can get this under the microscope for you guys. Where is it? Come on, can't see it. There's the pick. Oh, there it is. Right, let's give ourselves a flat base to work from at least. Yep, okay. Nice and clean. Put the component in. Should have had my other solder for that, but not to worry. She's in. What we like. Yep. Okay, let's try it out. Actually, I haven't actually tried these capacitors since I bought them in. Let's hopefully I've got the right ones. So this is the new one. Just one that's standard in there. Yeah, that looks pretty much, apart from some date code. Yeah, it looks like the same baby. So hopefully it won't give me any shocks or bangs. Let's have a look. That way around. It's actually not very city down on this one. Let's try. Can only go bang. Ah, that's better. Look at that. Beautiful. Yeah, she's asking. And she's at temperature. He's good. He's good. Right, so that's the fourth one repaired. And the other thing, it also shows, I've lost it now. I'll do that up. I think I've thrown it. There's capacitors. You need an ESR meter. As you remember, I actually went to capacitance, measured that capacitance. I wish I could find the component now. And the capacitance said it was okay on this, but this is almost DC, where the circuits run AC. The ESR meter is an AC device. It actually runs at 100 kilohertz, and that told me it was a faulty component or a shorted component to AC. this is why just measuring the capacitance won't always get you at the doo-doo. You need an ESR meter, and they're about £30 eBay, and worth every penny. That's saved me countless times. And this actually concludes this repair. We got 4 in the bag, so that's good. Okay, many thanks for watching. I hope that was interesting. Any questions? Yeah, please feel free to comment. I don't mind answering anyone's questions at all. And don't forget to subscribe if you like the video. Many thanks.